Me to get the hell out of my head. I'm gonna live inside the upside down for a minute and pretend. Honey, I'm a perfect 10. Whoa, honey, I'm a perfect 10. Whoa, and if I say it enough, it gets ingrained in my head, and I start to think, honey, I'm a perfect 10. Honey, I'm a perfect 10. Honey, I'm a perfect 10. Whoa, honey, I'm a perfect 10. 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 Oh. On my own, but I don't know why you hit the road, but you don't realize I won't look back when you're around. I won't think twice when you're gone. Don't hesitate to call me back, 'cause I won't be there. I won't look back when you're around. I won't think twice when you're gone. Don't hesitate to call me back, 'cause I won't be there. I won't look back. 'Cause I won't look back. I won't look back. 'Cause I won't look on my own. I don't know why. She told me it's not your fault, but you don't realize that I never want to watch the truth in your eyes. There's a light that makes me blush. I won't look back when you're around. I won't think twice when you're gone. Don't hesitate to call me back, 'cause I won't be there. I won't look back when you're around. I won't think twice when you're gone. Don't hesitate to call me back, 'cause I won't be there. I won't look back. 'Cause I won't look back. 'Cause I won't look back. 'Cause I won't look back, baby, tonight. 'Cause I won't look back. 'Cause I won't look back. I can feel it somewhere inside, haunting, like a drug I keep on wanting. There's a love that fits so perfect, it's hard to believe. There's a reason I can feel my heart stop beating, and the air gets tough just breathing. I'm alone, but I'm still feeling like someone's with me. It's strange, I know, but I feel like you're here with me. Like chasing ghosts, I know you're out there.
Ladies and gentlemen, we will now begin the second lecture of today's seminar. Just like the first one, we will also have a question and answer session after the guest speaker delivered the lecture. And participants who wish to ask a question regarding the lecture can write it down in Zoom's comment column, and it will be answered on the question and answer session. Before we start the second lecture, the participants may take a few minutes to fill the pre-test that is already provided by the committee. The second lecture will be about Beyond Building Information Modeling, Rethinking Business Model for Construction by Dr. Robbie. Dr. Robbie is a senior lecturer and program director of Construction Management School of Architecture, Building and Civil Engineering at Loughborough University, United Kingdom. He is an alumnus of Petra Christian University, and he finished his bachelor degree of civil engineering in 1995. Dr. Robbie received his master degree of engineering in construction management from Asian Institute of Technology, Thailand in 1998 and doctoral degree in construction management from University of Wolverhampton, United Kingdom in 2002. Being an excellent in his field, Dr. Robbie received a tremendous amount of awards, and among them, his latest achievements are Premier Award of the CIOB's International Innovation and Research Award 2005, also appointed as Principal Investigator for DECON, Digital Enablers of Construction Transformation, a new paradigm for rethinking construction from July 2019 till June 2020 via TCN Plus University College London. So without further ado, would you please welcome Dr. Robbie.
Thank you, Chair. Can you see my screen?
Yes, we can.
Yes. Yes, thank you for a very nice introduction, and also thank you for invitation to give a talk to this webinar. It is my pleasure to be able to give a talk, organized by my own alma mater, Petra Christian University. So, during this anniversary celebration, is it most appropriate if I pay some tribute to my alma mater? Yeah, so I was born in Kediri, small town near Surabaya. Yeah, so I graduated in 1995. Since then, I undertook research in construction management and being a full-time academic in the UK for the last 22 years. So I would like you to join pooling via vfox.apps. If you have a mobile phone, please join in using your web browser. And the meeting ID is 136.111.508. So we are going to have a little introduction about yourself, what you're doing, yeah. So I'd like to know, where are you now? So give you a few seconds. Yeah, so a lot of people joining. So just enter the text and press send if you wish. So it's keep increasing, right? So I think we have to stop from now. So just please maintain your contact with vfox.apps. So we are going to have more polling in the next few slides. Wow, there's a spread across Indonesia. You see, majority in Surabaya. Yeah, so good to see you all. So the next polling is how many years of work or industry experience do you have? So please enter a value and then send. Yeah. Right, keep increasing. Right, I think I have to close now. Wow, majority have 0 to 1 year experience. So most of you are students. So great. So most people would not associate change with the construction industry, especially not rapid change. But nevertheless, change is inherent part of any crisis. Any change is the reality of the current COVID-19 crisis, especially for construction. So with unprecedented impact on the global industry, companies are being forced to rapidly adopt innovative solutions. Right, so I'll try another polling. So if you can let me know your view. Right, I think I have to close. See what you think. Yeah, so most of you have actually think that COVID-19 has significantly accelerated the digital transformation. In fact, almost 90% there, which is very, very positive, I would think. So this is a survey of 400 decision makers in construction around the world. And it's been collected by McKinsey & Company, management consultant company in the US. And basically 2/3 of respondents believe that COVID-19 crisis has accelerated the overall transformation of the construction. And then over 50% company has started invest on to adjust to the new future. So which is in line with your view on the COVID-19. So in this webinar, I will discuss driving force beyond COVID, other than COVID-19, particularly looking at the adoption of digital technology for transformation in construction. So digital technology promise many benefits. However, 60 to 85% of digital initiatives have failed to deliver the benefit. The reason is not because the technology themselves, the technologies are available out there, but it is because other factors, human factors in the implementation and adoptions, and failure to consider contextual factor such as social and cultural as well as business context. So a specific question that I wish to address is, what is the most effective business model that can accelerate digital transformations? So we need to look at more what is the business sense of adopting digital technologies. So first, I'm going to look at BIM development in the past 10 years, focusing on adoption, and then I'll discuss the driver of change and emerging disruptions, and the current context of performance improvement in the UK on transforming construction agenda. And then I will look at 10 years, particularly presenting scenario, technology adoption process maps, and the business model. What is the most appropriate business model? There has been numerous published government and other institution reports promoting the use of BIM in the planning and design and construction process. The use of BIM was seen as the recipe for addressing poor performance, increasing efficiency and productivity. BIM brings together information in the same place through design, construction, and also will be useful for future operation and maintenance of facilities. To support the practice and measure development, this is a model of BIM maturity, to demonstrate the maturity level. As the maturity level increase, the information sharing increase in this case. So in 2011, the UK government mandated the use of level 2 for all publicly funded projects by 2016. So at the moment, there is a very little consensus on what is actually level 3 actually mean for practice. So we look at a traditional design process, which we call it over-the-wall design, where the design come from the architects and then throw to the structure engineers and then quantity surveyors and then go to mechanical service and engineers and then go to the contractor with very little communication. And BIM actually is trying to bring this together into much more iterative process, much more coherent collaborations rather than just throwing the design over the walls without any further sharing and sort of optimizing the design process itself. Yeah. So without sharing, without collaboration, this over-the-wall design process will lead to rework, a lot of waste, inefficiency in the process itself. So to address this problem, the designer need to collocate, so come to the same table to exercise the act of designing. They interact with each other in a co-production of knowledge. So the output is design drawing or 3D BIM model, if you like it. The quality of this technical output cannot be detached from socio-cultural input from the design team in the process itself. So collocation bring the benefit of audio, visual feedback and consensus in real time. So each member can fully understand the situation and be able to contribute in real time. So in the event that collocation is not possible, then the outcome can be compromised. So let's move on. So this is really, as you see in your screen, is we call it common data environment. So this is one of the most important aspect of level 2, level 2 BIM. Yeah. So common data environment, or CDE, is a standards for document and data management. So CDE has 4 folders: work in progress, share, publish, and archive folder. So each party has their own work in progress folder, work within it. When a party, say an architects, complete their design, they put in the share folder before the next party, the structure engineer pick it up and work on the design, and after that M&E engineer and so on. So the benefit is that all are working in an agreed approach. So there is a consensus, and this is the process BIM as a process is about. So, however, the input from the mechanical engineers is somewhat fait or comply after the fact, because the engineer are only able to contribute to the model development after the architect's thorough decision has been finalized and made available in the share folder. So this implies that many key decisions could have been taken in isolation. So there is some sort of an issue here with common data environment, which the industry is trying to solve. So ideally, the participant should be able to work together in remote situations, and they should be able to discuss of online means, such as what you have seen on the screen here. So the social and cultural input has to be taken, and design process itself, which has been seen as a linear in the past, so it should be iterative. So in this case, the process of optimizing design is carry on and goes on, and the input from each party in the process should be considered within BIM environment. So this diagram show a digital initiative in the UK. So since 2010, there has been a lot of initiative in terms of government strategies and all the all the white papers encouraging the use of BIMs and so forth, and as well as some of the funding from the government. So so currently we have in the UK, we have initiative called Digital Twin initiative. Within the it corresponds to Digital Twin initiative. We also have information, we call it the information management framework. So information management framework is developing a common language which party could share informations, what kind of information they have to share, yeah. And digital twin is really one of the recent advance in terms of BIM development. So just a simple kind of representation of digital twin. So digital twin is a realistic digital representation of assets, process, and system here. So every single object in the digital, in the physical world, it should be represented in the digital twin. So the beauty of it is there is some sort of interconnection between digital twin and physical twin here. So anything that is happening in the physical world could be simulated in the digital world, and any intervention we can try simulate in the digital twin, and we will be able to assess what would happen that in the physical world. So this will allow sort of what if scenario for decision making process, and would be beneficial in the long run. Yeah, so we'll be able to see the implication not just on the building but also on the ecosystems across the community, across the related aspect to it, such as transport, energy, and other aspects with regard to the built environment itself. But we need a common language, and this common language has been promoted by information management framework. So as I promised before, I'll look at really focusing on a BIM adoption, the adoption. So so yeah, this is a survey, which has been collected for the last 10 years by National Building Specification, this major institution run by Royal Institution of British Architects. Over the 10 years, 400 to 1,000 respondents participate in the survey, mainly from the UK. Yeah. professional institution participate, yeah, mainly architects, civil engineers, construction manager. And you can see there from 2011, there was only 13% aware of and using BIM. And then in 2020, we have 73%. So a 60% increase of professional using BIM. So bearing in mind that, despite this significant increase of BIM utilization, in the survey, people who tend to use, people who tend to use BIM actually tend to respond to the survey. Those who not really bother to use BIM, they want perhaps it's not very interesting to participate in the survey. Despite this increase, there are some pockets of industry that still not being touched by BIM. Yeah. But when we look at a bit further, what does using BIM actually means based on the same survey. So 25% associated using BIM with working with 3D parametric model. So it's just developing a model, 3D model. 37 and 26 consider the process if you combine those two, because PS 1192 and PS 1965 really as a consequence to each other, they are related somehow. So it's about 41% actually consider BIM as a process, which is again is a positive news. From another survey, very recent, 92% of design team are using email rather than the system that they are supposed to use for collaboration and sharing informations. And also 80% of the respondents struggle with version control. Again, this is very much reflect some of the issues with information sharing in the design process that is associated with BIM. So because most of you are really in Indonesia, so I thought it would be appropriate to consider BIM adoption in Indonesia. So from a number of literature, we'll see some of the key points that has been highlighted. So basically, low adoption, only in few construction projects. One of the reference say 20 companies use BIM, only 5 persist in good practice. So that's really very little in considering the whole scale of the number of construction firms in Indonesia. And also there is no BIM regulation, no institutional motivation, and also BIM are not client requirement. So at the moment, really still maturity level 1, that is really, you talk about a 3D model, a lonely BIM as it is without intention for sharing or optimize the decision making or optimize the model as itself. So it's focused on technology rather than process and policy criteria. And also there's a lack of understanding and awareness of collaboration benefits. So 3D BIM model as a tool rather than communications between stakeholder. Yeah, so communication still really a lot disjointed. Is not is not really connected very well. Yeah. So another survey. This is think piece by McKinsey and Company recently. So what are the driver of change in the next 15 years? So we have learned that there has been a lot of pressure from the customer. Customers now demand better quality, lower price, shorter time delivery. And also the construction industry itself, there is a scarcity of skilled laborers and so forth. And also the market rules and regulations, stricter regulation on energy, on pollutions and so forth. And also there's another pressures from in terms of the progress from outside construction in terms of new entrants from the investment company, from IT company that intend to invest in constructions. Also, the methods has changed as well. So we have industrializations, new material coming in, and also digitalization. And these two forces from the change of markets and emerging disruption actually come into shaping the industry as we would like to see in the next 15 years. So it's mainly product based, yeah, and increased specialization, consolidation, integrations, vertical integration across the supply chains, which we have seen in the past with aerospace industry. So now we have two major players, that is Boeing and Airbus. In the past, after the Second World War, there have been many. There were many companies. They are creating unique product. But in the 70s and in the 60s, this this company has merged into two big company. Yeah, that is Boeing and Airbus. And other pressures, other potential industry dynamic in the future, internationalization, sustainability also will become much more prominent in the next 15 years. And also we have an opportunity presented by industrial revolutions. We know about first industrial revolution, second industrial revolution, and then the third one. So now we are currently undergoing the fourth industrial revolution, which suggests that we can connect things. So we call Internet of Things. We are considering networks and how network can actually move together, bring together into interconnected objects. So that represents an opportunity for future development. So the three critical key attributes of Industry 4.0. Yeah, so I can suggest here that there is an automatic collection of operational data. Yeah, so without human intervention, and efficient data sharing via network. And then from there, there is also data analytics, some sort of intelligence that could be embedded within the systems. So that's a key attribute of Industry 4.0 that we should be able to capitalize in our future use of technology. So so this is again represent the position of BIM within digital ecosystem. So in the past, we focus on BIM as a point solution, that is IT offering that has a singular focus on one problem or one use case only. Yeah. An example could be a typical project planning apps. Yeah. So that is used disconnected from what is happening in the supply chain, on site, and meteorological risk and so forth. So this singular focus is lead to silo solution that makes real-time data inaccessible to other solutions. So you developing BIM model as it is, just to represent or just as a visualization, without taking advantage what is possible if we have we adopt a digital ecosystem approach, that we can connect different technology, different tools with BIM. Yeah. So with regard to construction 4.0, we have really goes to the principle of cyber physical space, where we have a digital layers and then we have a physical layers. So digital layers really on the design on the top there, and then you know, physical layers is on the construction side. And on the top here, we have digital tools such as drones, cloud-based project management, AR or VR, artificial intelligence, cybersecurity, big data analytics, blockchain, and so forth. And in the construction side, on the physical side, you have robotic automations, you have sensor, IoT, smart network, additive manufacturing, and so forth. Yeah, so we need to look at you know, further progressions from point solution as we normally see within BIM applications to much more wider, and see how we can expand to an ecosystem, digital ecosystems that can take advantage of Industry 4.0 movement. Yeah. Right. So you know, in the UK, we have in the past sort of 5 years, we have we call it transforming construction agenda. So how we can implement, or how can we move the industry forward, given the opportunity given by the technology itself, and also use that opportunity, use the capability, use the technology to actually improve the construction, improve the performance. That is reducing costs, increasing speed of delivery, lowering emissions, and you know, other competitive key performance indicators. So initiated by you know, a government report about entitled Construction 2025, and then probably about 3 years ago we have industrial strategy that is really suggesting the use of digital techniques, offset manufacturing, whole life asset performance to achieve the performance targets. You know, lower cost, faster speed, lower emission, and so forth. So what does it mean really? So we build a component in the factory. So we move to offsite manufacturing. So producing component in the factory that we can integrate a plumbing work, electrical and mechanical work within the component, yeah, rather than build on site, and then try to assemble panel in the factory again, and then bring to the site. Well, you know, I would suggest that this is not new. You know, we have seen all these things before. I mean, in the past 25 years, we have seen prefabricated manufacturing concept. But however, there is something different here, because what we're trying to do is to embed the capability presented by Industry 4.0 in the you know, offsite manufacturing and on-site assembly process. Yeah. So there are a few development, you know, not new, but really the take-up is pretty little. Just few percentage of you know, construction sector use the approach. You know, it's not new, but it's the take-up is slow. You know, there are major initiatives such as Backlog here by major Swedish contractor Skanska, collaborating with IKEA, the furniture, flat pack furniture producers. So they produce a house based on standardized component produced in the factory. Yeah, so they have a number of market in Western Europe, Sweden, Norway, Finland, and in the UK. Yeah. And another example is Katera in the US, they use concept called building platform, which encompass a catalog of components which are standardized, but could fit into different building. This permit combine standardization and customization of the product. Customization is to meet different user requirement. The platform, I would like to stress on the platform here, building platform. The platform a set of components that interact in very well-defined ways, yeah, to allow a range of product and service to be produced. So the term platform itself is often used in software and manufacturing industry, where systems based around platform has both supported rapid innovations and form a basis for growth and value here. So an example of platform is car chassis. If you see between Ford and Jaguar in the past using the same chassis because they are owned by the same business entity, yeah. But they can using the same chassis, it can they can come up with two different products for two different market segments. Yeah. So this is an example of what Katera has produced here. So it's a bath kit. So it's only need 2 hours. Well, 2 people, and would require 4 hours to install. So that's what you can see. What is the final product on the right hand side here. And another example in the US is we call it Project Frogs. So Project Frog is very clever idea in terms of vertical integration, integrating the players to produce manufacture component. So they have a standard kit of parts platform. Yeah, so they specify a kit of part platform, and they also have technology platform in terms of the design software, in terms of integration software that can really work between between parties. So they have sort of have solved the interoperability problem, and also they have a standardized process implementation, and they train the workers, and they know they are working on the same design process, if you like. And this is an example of integrations of of the process itself. Yeah? So we come to a business sense here. We talk about the technology. So let's talk about whether we can make a business sense of what we have seen here. So another study by McKinsey. So it's very interesting here because it actually mapped out the value, yeah, a value across the value chains. That is from development, design, manufacturing of the components, suppliers of material, and then offsite production, construction, and so forth. So if we look at the whole process here, and the study actually suggests there will be a shift in values to offsite manufacturing of components. So 20 to 30% will shift to offsite. Well, you shift to offsite means there is something has to sacrifice. That is, in here we see on the let's see whether I can pinpoint laser pointer here. So you see here. So this is the area that is going to shift. Yeah. So it's a lot of red area here is the value that is going to shift to offsite. And you see here the general contractor actually will reduce the value, and general contracting will be reduced. And in total, 40 to 45% of the value at risk. Yeah, and these values it has a lot of implication in construction. If you can imagine 45% of the shifting in value here. If we look at construction output in Indonesia, this is based on BPS, Badan Pusat Statistics. Yeah, I say that in 2018 we have 1,272 trillion of construction output, and 45% is 572 trillion rupiah. So this is 87 billion US dollars. So it's still very significant values. There is a shift here. Right. So in the start of my presentation, I said that the industry is really difficult to change, and this is represent kind of a typical construction site conditions, yeah, which a lot of implication on productivity and so forth, and how we can transform future. So how can we transform this typical site to something similar to what you've seen on the right-hand side here, and also how we can use technology appropriately to help us to achieve a better outputs, and also how can we improve the skill. So in the past year, I and my team conducted a research project called DCON, Digital Enabler for Construction Transformation. So so DCON, see common problem in construction, could be addressed by appropriate enabling digital technology, yeah, and defining future delivery process information industry, and we kind of investigate this relationship between the context, socioeconomics, government policies, and regulation, cultural and structural context of construction, and then we sort of looking at the pathway. How can we map out the pathway to transform future enabled by high payback digital technology. So so it is critical that the possible pathway to move to the current state or to transform future I explore here, and determine and examine and what are the possible outcome of it. Yeah. So we use a scenario planning approach. So the aim is not to predict future, but is to explore possibility, yeah, and to determine strategy and business model. So the methods we use interview, focus groups, workshops, through a number of steps there, and then we run all the workshop to refine our scenario. And this is the finding, yeah, the some of the key themes that we can actually synthesize from the data collection process, yeah. So I don't want to go into much detail, but really, you have driving force, you have barriers, you have policy and business model, and within that, there's sub themes. Yeah. And the next step was to conflate, this theme into two intersecting axes. Yeah. And then, the emerging theme, as we seen earlier, is further classified into two driving force. Or uncertainty here, and we name them as integration and collaboration, and the second group we name it innovation and R&D. Yeah. So the classification was not an exact science, but was an approximation, and some fall into the one on the left, and some fall into the one on the right, and some is between. Yeah. And we come up with scenario, yeah. So we based on the two axes, the two main theme. We have two extreme, yeah. Basically, one is fragmentation and integration, isolation and collaboration, and high innovation and R&D and low innovation and R&D, and we come up with scenario on each quadrant, if you like. This is our kind of analysis. I don't expect you to read. It's very perhaps it's very complex here. But it's really, we have dominant drivers such as self-interest, isolationism, global concern, investment, and corporate movement here. But it's really what I would like to say here, basically in terms of what we found from the process, that the company need to consider investment. The investment should come from top down, from the government and so on, but also from bottom up, that is from the construction company itself, as well as considering merger and acquisitions, considering investment from IT companies such as Google has invested in several future ventures. Finance institutions such as Goldman Sachs also has invested in house building prefab manufacturer in the UK as well. There's some sort of new entrance to the industry. So we have a corporate movement that is really looking at increased collaborations between increased collaboration, not just between, as I said before, not just between the construction company in the industries, but also looking at wider ecosystems and what kind of benefit that construction company can collaborate, if they can collaborate with other in the IT sectors or in the manufacturing space as well. So considering a wider collaboration and what kind of things that this company can benefit from collaborating from outside the usual ecosystems in the construction industry. So this is some of the prominent Industry 4.0 technology. We use this technology to actually build our technology adoption map, for future 10 years. So it's really, this is talking about, big data, industrial Internet of Things, the cloud, autonomous robots, augmented reality, cybersecurity, simulations, and additive manufacturing. I mean, there are plenty there, for us to digest, and I don't want to go into much detail here, but so now be ready for our next sort of polling. I hope you still online with VFox. So if you can tell me what technology will be prominent, popular in the next 5 years.